Hey everyone, welcome back to the channel. So you've decided to learn Java, you've downloaded something called the JDK, and now you're seeing terms like JRE, JVM, bytecode, class loader, and you're wondering what any of this actually means and why it even matters. Today we are clearing all of that up. By the end of this video, you'll understand exactly what JDK, JRE, and JVM are, how they relate to each other, and which one you actually need to install. Let's get into it. Let me start with a simple analogy that makes this click immediately. Imagine you want to watch a movie at home. You need three things: the movie file itself, the actual content, a media player, software to play it, and a TV or screen to display it. Without any one of those three things, you cannot watch your movie. Java works exactly the same way. To run Java programs, you need your Java code, the program you write. You need the JDK or JRE, the development and runtime tools, and you need the JVM, the engine that actually executes your code. So let's define all three right now before we go deeper. JVM stands for Java Virtual Machine. It's the engine that actually runs Java programs. Think of it as the smallest, innermost piece. JRE stands for Java Runtime Environment. It's the JVM plus the libraries needed to run Java programs. Think of it as the middle layer. JDK stands for Java Development Kit. It's the JRE plus all the development tools you need to actually create Java programs. Think of it as the biggest, outermost layer. The relationship between them is like Russian nesting dolls. JVM sits inside JRE. JRE sits inside JDK. JDK is the biggest and contains everything. This is the most important thing to understand from this entire video. They are nested inside each other, not separate competing products. Let's start with the JVM, the Java Virtual Machine, because this is the heart of everything. The JVM is a virtual computer that runs inside your actual computer. It executes Java bytecode. Here's the analogy I love for this. Imagine you have a DVD from Europe in PAL format, but you live in America where the standard is NTSC. Normally, it wouldn't work. But what if you had a magical DVD player that could play any format from any region? That's exactly what the JVM is for Java. Here's the problem it solves. Different computers use different processors. Windows runs on Intel and AMD processors. Mac now runs on Apple Silicon, which is ARM architecture. Linux runs on various processors. Android runs on ARM. Without JVM, you'd need to write a completely different version of your program for each platform. With JVM, you write your Java code once, compile it to something called bytecode, and the JVM on each platform handles translating that bytecode into instructions that specific machine understands. So the flow looks like this. You write your Java source code in a .java file. The compiler converts it to bytecode stored in a .class file. That bytecode is platform independent, the same everywhere. Then the JVM on Windows, Mac, Linux, or Android each reads that bytecode and converts it to the native machine code for that specific platform. This is the famous write once, run anywhere promise of Java. Now let me walk you through what's actually inside the JVM, because understanding this makes you a much better developer. The first component is the class loader subsystem. This is responsible for loading your .class files into memory. It does this in three phases. Loading, it reads the .class file from disk and brings the bytecode into memory. Linking, it verifies the bytecode is valid and safe, allocates memory for static variables, and resolves references. And initialization, it runs static blocks and initializes static variables. Think of it like a librarian receiving a new book, checking if it's genuine, cataloging it, and placing it on the correct shelf. The second component is runtime data areas, essentially the memory regions where JVM stores different types of data. The method area stores class structures, method information, and static variables. It's shared by all threads. The heap stores all your objects and instance variables. When you write new student, that student object lives in the heap. The heap is shared by all threads and is garbage collected automatically. The stack stores local variables, method calls, and partial results. Every thread gets its own stack. When you have a local variable inside a method, it lives in the stack. The PC register is like a bookmark. It stores the address of the current instruction being executed. And the native method stack handles calls to native methods written in C or C++. Let me show you this with a quick code example. If you have a static variable, it goes to the method area. If you have a local variable inside a method, it goes to the stack. If you create an object with new, The reference variable goes in the stack, but the actual object lives in the heap. And a string literal like hello also lives in the heap. The third major component is the execution engine. This is what actually runs your bytecode. It has three parts. The interpreter reads and executes bytecode line by line. It starts fast, but is slower for repeated code because it reinterprets every single time. Think of it like reading a recipe step by step every time you cook. The JIT compiler, just-in-time compiler, is smarter. It watches which parts of your code run frequently, called hot code. When it identifies a hot method, it compiles it all the way to native machine code and caches it. So all future calls use the fast native version instead of interpreting again. Think of it like memorizing the recipe after you've made the dish several times. Much faster. And the garbage collector automatically finds and removes objects in the heap that are no longer reachable. This is one of Java's biggest advantages. You don't manage memory manually. If you set a reference to null, the garbage collector will eventually free that memory for you. There are also multiple JVM implementations. Hotspot from Oracle is the most common and the one you'll use by default. OpenJ9 from Eclipse and IBM is optimized for cloud and low memory usage. GraalVM from Oracle is high performance and supports multiple languages. And Android Runtime is Google's optimized version for Android devices. For beginners, Hotspot is what you want, and it comes with the standard JDK. Now let's talk about JRE, Java Runtime Environment. The JRE is everything you need to run Java programs, but not to develop them. Think of it like a video game console like PlayStation. As a player, you just need the console and the system software to play games. You don't need game development tools. The JRE is that console for Java. It lets you run applications without letting you create them. What's inside the JRE? The JVM, which we just covered, core libraries like java.lang, java.util, java.io, java.net, and javax.swing. Deployment tools and configuration files. Who needs the JRE? End users, people who just want to run Java applications. Think running Minecraft Java Edition using LibreOffice, which has Java components, or running any Java desktop application. Here's the flow. A developer writes and compiles Java code into a .jar file. You download that .jar file, you double-click it. The JRE's JVM executes the bytecode. The app runs on your computer. Without JRE installed, you'd get an error saying Java is not installed. One important note, if you're a developer, you don't need to install JRE separately. The JDK already includes the entire JRE inside it, and many modern applications actually bundle their own runtime, so you might not even need to install anything. Now let's talk about the JDK, Java Development Kit. The JDK is everything you need to develop and run Java programs. JDK equals JRE plus development tools. If JRE is the PlayStation for playing games, then JDK is the complete game development studio, with all the tools, compilers, debuggers, and testing equipment. What's inside the JDK? The entire JRE, including the JVM, plus a comprehensive set of development tools. Let me walk you through the most important ones. Javac is the Java compiler. You give it your .java source file, and it produces a .class bytecode file. This is the first tool you'll use every single time you write Java code. Java is the application launcher. You give it your compiled class, and it runs your program. You'll use this right after Javac. JavaDoc generates HTML documentation from special comments in your source code. You write comments in a specific format, run JavaDoc, and it creates professional-looking documentation automatically. jar is the archive tool. It packages your .class files and resources into a single .jar file, Java Archive. This is how you distribute Java applications. You can then run that jar file with java-jar. JDB is the Java debugger. It lets you set breakpoints, step through code line by line, and inspect variable values while your program is running. JAPOP is the disassembler. It shows you the bytecode inside a .class file. Very useful for understanding what the compiler actually produced, and for advanced optimization work. And JShell, added in Java 9, is an interactive REPL, read, evaluate, print loop. You can type Java expressions and see results instantly without writing a full class or main method. Perfect for quickly testing snippets of code. You type int x equals 5, press enter, and it immediately shows you x equals 5. Type x plus 10, and it shows 15. Super useful for experimentation. Who needs the JDK? Every developer. Students learning Java, professional software developers, Android app developers, back-end developers, game developers. If you are writing Java code, you need the JDK. Full stop. Let me now give you the complete comparison so this is crystal clear. JVM, Java Virtual Machine, executes bytecode, is the smallest piece, can run code but can't compile, and is never installed on its own. JRE, Java Runtime Environment, runs Java programs, is medium-sized, contains JVM plus libraries, can run code but can't compile, and is for end users. JDK, Java Development Kit, develops and runs Java programs, is the largest, contains JRE plus development tools, can both compile and run code, and is for developers. All three are completely free. Let me give you the car analogy because it makes this stick perfectly. JVM is the car engine. It does the actual work, running the code. It's platform-specific, different for each operating system. You don't interact with it directly. JRE is the complete car, engine plus body plus wheels, everything you need to drive, for passengers, end users, who just want to get from A to B, cannot build or modify cars. JDK is the car plus the entire manufacturing workshop, everything in the complete car, plus all the tools to build, modify, diagnose, and repair cars. For mechanics and engineers, developers. Now let me walk you through the complete execution flow from code to output, because seeing the whole picture is really satisfying. Step 1. You write your source code in a .java file. You create a class with a main method and your logic. Step 2. You compile with Javac. The compiler reads your .java file and produces a .class file containing bytecode. This bytecode is platform independent. Step 3. You run with the Java command. This starts the JVM and tells it to execute your class. Step 4. The JVM execution happens. The class loader loads your .class file into memory. The bytecode verifier checks that it's valid and safe. The interpreter starts executing instructions. The JIT compiler identifies frequently called methods and compiles them to fast native code. Your program executes, system.out.println runs and prints your output. And when it's done, the garbage collector cleans up any objects that are no longer needed. Step 5. You see your output. That's the complete journey from Java source code to running program. Let me quickly bust some common misconceptions, because these trip up a lot of beginners. Misconception 1. JDK and JRE are separate competing products. Wrong. JDK contains JRE. They are nested, not separate. Misconception 2. You need to install both JDK and JRE. Wrong. If you install JDK, you already have JRE included. Never install both separately. Misconception 3. You need to download JVM separately. Wrong. JVM comes included with both JRE and JDK automatically. You never install JVM on its own. Misconception 4. Java bytecode is the same as machine code. Wrong. Bytecode is intermediate code that is platform independent. The same .class file works everywhere. Machine code is platform specific, different for each CPU and operating system. The JVM is what bridges that gap, converting bytecode to machine code at runtime. One more important thing. OpenJDK versus Oracle JDK. OpenJDK is open source, community-driven, and always completely free. Oracle JDK is controlled by Oracle, free for development but requires a paid subscription for production commercial support. Performance is nearly identical between the two. For beginners and most professionals, OpenJDK is the perfect choice. Free, no license concerns, and fully compatible. For enterprise environments that want Oracle's official commercial support, Oracle JDK makes sense. Let's wrap up with the key takeaways. The hierarchy: JDK contains JRE, JRE contains JVM, JVM executes your bytecode. What to install? Learning Java means install JDK. Developing Java apps means install JDK. Just running Java programs means install JRE. And never install JVM separately because it's always included. The magic of Java: write your code once in a .java file, compile it once to .class bytecode, and run it anywhere because the JVM handles the platform-specific translation on every operating system. That's the beauty of the Java architecture. One language, one compilation, infinite platforms. And that is JDK, JRE, and JVM completely explained. Now that you understand the architecture, the next step is to actually install Java on your machine and write your very first Java program. That's exactly what we're covering in the next video. If this helped you, hit that like button, it genuinely helps the channel, and subscribe so you don't miss the next one.